Imagine if the first maps of our world didn't come from people climbing mountains or building towers, but from a view we only managed to reach in the last 70 years. What if the oldest star charts in human history aren't just the scribbles of ancient stargazers on the ground, but actual memories from above? Down in the climate-controlled vaults beneath Yale's Babylonian collection, where nothing ever really changes, thousands of clay tablets sit quietly in padded trays. They're like echoes from a time when people thought the stars were closer, when they tracked planets with a focus that feels almost impossible now, and when whole cities were laid out in patterns that only really make sense if you imagine someone watching from the sky. Before we get lost in the strange geometry of ancient people, I've got a small favor to ask. If you're into stories that chase the impossible, consider subscribing. And if you're reading this late at night, let me know where you are and what constellation you see above your city. I want to picture this story drifting beneath the same stars the Sumerians once mapped with such eerie accuracy. This story doesn't start with a telescope. It starts with a handful of broken clay. In the spring of 1880, a British archaeologist named Hormuzd Rassam dug into the old city of Sippar, a place the Sumerian king list claims existed before the flood. For weeks, his team had been pulling out the usual bits: temple library fragments, records of grain, legal squabbles, hymns to gods no one remembers. But one afternoon, under a wall that had somehow stood for 4,000 years, they found something different. Tablets, packed with dense cuneiform, laid out in columns, listing numbers and star observations in a way that feels more like science than myth. The dig at Sippar wasn't some gentle academic stroll. Iraqi summers regularly hit 120 degrees. The sun was brutal. Workers started before dawn, digging through layers of hard-packed earth that had built up over thousands of years. The old mud brick buildings had collapsed inward, creating a layer cake of civilization, each stratum telling its own story, each one built on the bones of what came before. And somewhere in that dirt, preserved by the very destruction that buried them, those star tablets waited. Sippar itself was once a kind of intellectual powerhouse. It's where priests of Shamash, the sun god, watched the sky and built reputations that spread across the ancient world. The city sat on the Euphrates, just north of Babylon, right at a crossroads where traders and travelers brought new ideas. From the early dynastic period through the Neo-Babylonian Empire, over 2,000 years, Sippar had been a place where people tracked the planets with a devotion that sometimes tipped over into obsession. When the city finally crumbled in the early centuries of the Common Era, when the last priests gave up, when the canals filled with silt, and the desert began swallowing the fields, the knowledge didn't just disappear. It literally went underground, hidden beneath fallen walls and drifting sand, waiting for hands that wouldn't come for another 1,500 years. Rassam's workers could tell they'd found something special, even if they couldn't read a single sign. The tablets were organized, stored in the right rooms, some still wrapped in clay envelopes that had protected them before fire gutted the building. This wasn't some random stash of old receipts or personal notes. These were archives, knowledge carefully preserved for whoever might need it, for generations that hadn't even been born. When Rassam's team dug the tablets out of the rubble, they were caked with ancient dirt, so much that you could barely see the cuneiform marks under all that grime. Workers took their time, brushing off the dust and rinsing them with water, and slowly those wedge-shaped impressions started to show through. The clay had been baked hard when it was first made, and then, by a twist of fate, baked again when fire swept through the building that stored them. That second firing saved them. If the tablets had stayed unbaked, they would have just melted away in groundwater over the centuries. But fire turned them into ceramic, tough enough to last forever if nobody smashes them. As the tablets dried out under the desert sun, the writing grew sharper. Columns of numbers and strange astronomical notes started to pop out. Scholars would spend the next 100 years trying to puzzle out what those marks meant. They weren't random, far from it. The records were neat, methodical, clear proof that someone had been tracking the sky with real discipline and mathematical skill. The tablets focused on Venus, that bright morning and evening star, second only to the sun and moon in the night sky. The level of detail was almost unbelievable for people working with nothing but their eyes and a few simple tools. Later, when the tablets made it to the British Museum, scholars got down to the slow work of translating them. What they uncovered was astonishing. Decades worth of data, not idle sky-watching or poetic rambling, but cold, careful records of Venus's appearances. They tracked Venus's rise and fall over a 21-year stretch, noting each time it first showed up in the dawn sky, how long it stayed visible when it vanished behind the sun, when it returned in the evening, and how long each phase lasted. This wasn't fortune-telling. This was astronomy, and it was spot-on. They traced the records back to the reign of King Ammisaduqa of Babylon, around 1650 BCE. But right away, something didn't add up. The predictions were too good, almost like the tablets were copies of even older observations. Venus isn't easy to predict if you only watch it for a little while. Its cycle, the synodic period, takes about 584 days, and it drifts through the calendar, shifting seasons over decades. To map out its full pattern and predict its path the way these tablets did, you'd need observations stretching over generations, even centuries. That means people had to keep watching, recording, and comparing notes for ages, passing down knowledge from one group of skywatchers to the next. The tablets themselves don't explain how they got all that information. They just present the data, plain and unadorned, as if copied straight from an ancient reference book. On one battered edge, there's a note in Akkadian, according to the old observations of Anu and Enlil. Anu and Enlil, these are the great gods of Sumerian myth, but here they're listed almost like historical astronomers, the original watchers of Venus whose records later generations simply copied. And when you really think about that, it's kind of mind-bending. Either the Sumerians and Babylonians managed to keep uninterrupted astronomical records for thousands of years, surviving wars, disasters, and the collapse of kingdoms, or they picked up where someone even older left off. Both options are wild. One points to a level of stability and dedication that's hard to imagine today. The other hints at something stranger, that, long before Sumer emerged from the Mesopotamian mud, someone else was already watching the sky, taking careful notes, and making sure those records would last. Imagine yourself in the quiet just before sunrise, standing in a Sumerian temple courtyard, maybe around 2500 BCE. The air's cool, and the desert wind carries the damp smell of irrigation canals and the faint tang of oil lamps still burning deep inside the temple. You look up, no city lights, no haze. The sky's a sharp, endless dome. Every star stands out. Planets drift slowly, right where you expect if you have the patience to watch. The Milky Way stretches overhead, thick and bright, almost like you could walk across it. The old stories say it's a bridge, tying heaven and earth together. You're a priest astronomer, someone trained to watch the sky and make sense of it. You keep the temple's clay tablets filled with marks and numbers tracking Inanna's star, the planet we call Venus. Tonight, your job is the same as your teacher's job and their teacher, going back further than you can even trace. You stand there waiting. You know Venus will appear just before dawn, slipping up over the horizon in the east. You watch for the first glimmer, then mark the exact day and time. You count. You record. You press the stylus into wet clay, making careful marks you know will last for thousands of years. Maybe even puzzle people from a time when humans looked down at Earth from space, a view you can only imagine. But there's something that nags at you in the quiet of that watch. The old records you're copying from, their predictions actually match what you see. Not just close, but almost perfect. When they say Venus will rise on this day in this spot, it happens. They're off by less than a day across decades. You'd expect a slow grind toward accuracy, models getting tweaked, mistakes getting fixed as generations learn. But that's not what you see. The data's just too good, too clean. It feels like someone had better tools or better math than anyone's supposed to have in Bronze Age Mesopotamia. And it's not just the Venus tablets. In the University of Pennsylvania Museum, where they keep thousands of tablets dug up from Nippur since the 1880s, you find the same thing. Records tracking the moon, Jupiter, Saturn. Tables charting retrograde loops, conjunctions where planets sit among the constellations. All of it so precise it's unsettling. Not because you think ancient people were careless, they clearly weren't, but because this level of precision hints at something bigger. You start thinking about what it would really take. Whole institutions for observation, schools training astronomers generation after generation, temple libraries keeping records safe for centuries. And then the weirdest part, why? Why would these people pour so much energy and time into tracking the sky, way beyond what you'd need for astrology or farming? The usual explanation is astrology. Mesopotamians thought what happened in the sky mattered down here. If you knew how to read the signs, maybe you could predict the future. Kings wanted to know if their campaigns would work out. Priests wanted the right moment for rituals. Sure, the omen texts spell this out. If Jupiter shows up in Taurus, the king will rule a long time. Or if Venus vanishes too long, drought's coming. These beliefs shaped big decisions, no question. But astrology alone doesn't get you this kind of data. It's about spotting patterns, yes, but you don't need this level of math or precision just to know if a certain conjunction is good or bad. Honestly, the numbers go way beyond what's practical. It's like if weather forecasters today ran models not just for next week, but for 100 years out, and actually got it right. All this careful work suggests there was another reason, something deeper. Maybe it was about keeping a tradition alive, even if no one remembered exactly why. Maybe the methods mattered more than the reasons, and people kept the practice going because letting it go would have meant losing something vital, even if they couldn't say exactly what that was. What if the point wasn't prediction at all? What if it was about holding onto something, preserving knowledge, not guessing the future? Maybe these tablets were desperate attempts to keep records of observations from a world that had already slipped away. Maybe the people who wrote them had tools or ways of seeing that vanished long before anyone thought to ask why. The Mesopotamian astronomers might have meant exactly what they scrawled in those margins, copying old notes, keeping the line unbroken back to the Anunnaki, the ones who, according to legend, came down from the sky and taught humans to watch, to write, to remember. When archaeologists dug up Nippur in the late 1800s and early 1900s, starting with that University of Pennsylvania crew in 1889, they uncovered more than just tablets stuffed with numbers and stars. They discovered a city that didn't fit the usual mold. Nippur was never a political hub. No palace, no throne, no empire, no chokehold on trade. Yet everyone called it the religious heart of Sumer, the place where heaven touched earth, the world's belly button. Every king who wanted real power had to get crowned in Nippur's temple. Every scribal school in Mesopotamia pointed back to Nippur as the source of its authority. Its influence wasn't about armies or gold. Nippur ran on ideas and spirit. It was the vault of knowledge, the place that guarded traditions reaching back before the flood. Back when, as the old stories go, the Anunnaki still walked among people and set up the rules for how civilization was supposed to work. That Pennsylvania expedition was huge for its time. John Punnett Peters led it, a Hebrew professor who turned into a Babylonian archaeology expert. They spent years out there, fighting through heat, disease, tribal clashes that sometimes forced them to pack up and leave. Cholera and dysentery killed workers. Equipment fell apart in the blazing sun. Money was always tight, depending on whether wealthy folks in Philadelphia could be convinced that digging in a rock was worth it. But the team kept going. They knew they were onto something big. Nippur wasn't just another dusty ruin. It was the brain of Mesopotamian civilization, the place where scribes wrote the rules, where math and astronomy got saved and handed down. Especially in the Nippur temple, dedicated to Enlil, they found thousands of tablets covering 2,000 years of teaching and learning. Some tablets were just schoolwork, kids practicing cuneiform, repeating signs until their hands stopped shaking. Others had math problems, astronomy logs, poems, hymns, spells, contracts, admin stuff. What really hit the team, though, was how much stayed the same. Tablets centuries apart used the same math, logged the same stars, credited the same ancient sources and wisdom of the gods. It's almost like Nippur existed on its own timeline. Its job wasn't to invent new things, but to keep the old knowledge alive. The scribes weren't out there breaking new ground. They were copying, guarding, holding onto what they believed came from an age when the gods themselves taught people how to live. Even the city's design tells that story. Nippur wasn't laid out for war or for trade. Its temples and the Ikur ziggurat didn't follow practical lines. They followed the stars. The city's main buildings lined up with astronomical coordinates. When researchers mapped everything out and compared the layout to major stars and planetary stations, they found real connections, not just vague symbolism, but actual mathematical ratios, precise and deliberate. That's the kind of detail that still makes archaeologists pause and wonder what those ancient scribes knew, and what exactly they were trying so hard to save. If you measure the distance between the Temple of Enlil and the Temple of Inanna in Sumerian cubits and then convert that to modern units, you get a 3:2 ratio. That's not just some random chance. This same ratio pops up everywhere in Sumerian culture. Musicians know it as the perfect fifth, the interval Sumerians used for tuning their lyres and harps. They even built that proportion into their temple rooms to get the acoustics just right. But there's more. That ratio shows up in the sky, too. The orbital period of Saturn compared to Jupiter is about 5:2, not quite 3:2, but close enough to make you think they saw patterns between the planets. Venus's synodic period, 584 days compared to the solar year, 365 days, gets you close to the golden mean if you track it over time. These aren't rough guesses. They're baked into the architecture, almost like the city was designed to mirror how the heavens move. You see the same thing in other Sumerian cities. Take Uruk, with its huge defensive walls and the white temple for Anu, the sky god, or with its massive ziggurat and royal graves. Eridu, which people say is the oldest city, housed the temple of Enki. Lagash was famous for its irrigation and bureaucratic records. Each of these cities sits at a distance from the next that lines up with astronomical ratios. When researchers mapped out where all these places were, it was clear they weren't just picking spots based on farming or water. It looked like they were laying out a map of the stars right on the ground, turning the land into a mirror for the sky. Uruk really stands out. It was the blueprint for Sumerian cities, the one everyone else copied for centuries. When German archaeologists started digging there in 1912, they knew it was important, but the reality blew them away. At its peak, Uruk sprawled over 6 square kilometers and maybe sheltered 80,000 people. Parts of the city walls still rise more than 6 meters high, even after 4,000 years of wind and rain. Those walls weren't thrown together. They're feats of engineering, millions of mud bricks, each one made, moved, and set in place with incredible care. Archaeologists crunched the numbers and figured out it would have taken thousands of people, working together for decades, to build them. Not slaves like people used to think, but skilled workers, brick makers, surveyors, architects, foremen, people who understood logistics and could manage a huge project year after year. Still, as stunning as those walls were, they're not the heart of Uruk. That honor goes to the temple complexes, especially the white temple perched on its massive platform. The temple got its name from the bright white plaster that once coated its walls. It must have shone for miles, a beacon across the flat land, tying earth to sky. When archaeologists finally measured the platform under the white temple, the geometry was almost shockingly precise. The corners line up almost exactly with the 4 cardinal points, off by less than a degree. That's not eyeballing it. That's careful measurement, probably with tools and math we didn't think they had. When you run the numbers in Sumerian units, you see ratios that match up with things like the number of lunar months in a year or other astronomical cycles. Tells a similar story, even if the details are different. Leonard Woolley dug there in the 20s and 30s and found the Great Ziggurat, which was rebuilt in the 20th century and again in the 1980s. That ziggurat is lined up perfectly with true north, with 3 stairways meeting at the top, where the shrine to Nana, the moon god, once stood. But the ziggurat was more than a religious site. It was an observatory, too. Its levels matched the 7 classical planets, and from the top, priests could watch the sky in every direction, tracking the movements of the stars and planets without anything blocking their view. Woolley's digs at turned up something unexpected, something that circles right back to our big question about knowledge and perspective. In the royal cemetery, surrounded by all that glittering treasure, the famous standard of Queen Puabi's gold jewelry, he came across a handful of clay tablets. At first glance, they looked like plain survey records, just lists of distances between landmarks around the city. But here's the wild part. The measurements were so precise that even with modern GPS, surveyors today find they match within a few centimeters. But then things get weird. Woolley noticed, and people are still scratching their heads over this, that some measurements on those tablets include corrections for things Bronze Age surveyors supposedly shouldn't have known. They adjust for elevation differences between points. They compensate for the curve of the Earth over long distances. The math assumes the ground is curved, not flat. These aren't obvious tweaks. You'd only spot them if you really dug in. But they're there, baked into the numbers, hinting that whoever made these tablets understood more about the Earth's shape than we give them credit for. Then there's Eridu, the oldest and honestly the most mysterious site of all. Sumerian tradition calls it the first city, the place where kingship descended from heaven. It's been sacred longer than any other spot in Mesopotamia. Back in the 1940s and 50s, when Fuad Safar and Seton Lloyd led Iraqi teams digging beneath the visible ruins, they found something no one expected. They didn't just find one ancient temple. They found 17, stacked one on top of the other, each rebuilt on the remains of the last. That's nearly 3,000 years of continuous worship from the Ubaid period, around 5400 BCE, right up to about 600 BCE. The real surprise wasn't just how long people kept coming back. It was how little they changed things. The oldest temple at the very bottom, Temple XVI, was tiny and simple, a rectangle with an altar and an offering table. But its layout, its orientation, where the altar and doorway sat, all of that matched the very last temple, built 3,000 years later. 17 generations of builders, through shifting dynasties, new rulers, entire empires rising and falling, rebuilt the temple exactly the same way each time. Not close, not almost the same, exactly. Sure, later temples were bigger to fit more worshippers, but the underlying plan never changed. It's like the pattern itself was sacred. Change it, and you risk breaking the link to the original, the one the Sumerians believed the gods had set down when kingship first landed on Earth. When you stand in the trenches at Eridu now, peering down through all those layers, you're staring at proof of what their old texts keep saying. These people built their civilization around preservation. They wanted to keep the connection to their origins and to what they believed was divine, intact, no matter what. Now picture looking at a map of ancient Sumer from above, the way only satellites let us do. The cities sprawl across the plain, joined by old canals and trade routes. But if you measure the distances between the main cities and start comparing those numbers to astronomical constants, strange patterns pop up. Nippur to Uruk, about 160 kilometers. Uruk to 50 kilometers. To Eridu, around 20 kilometers. And when you convert those numbers into Sumerian units, they line up with planetary orbits and synodic cycles. It almost feels like someone laid out the whole civilization using a cosmic blueprint, putting cities in places that map the sky right onto the land. As above, so below. People know that phrase from later Hermetic texts, the Emerald Tablet, all that. It means Earth mirrors the heavens, but the idea stretches way back deeper into Mesopotamian tradition. You see it in their city layouts, their temples, their star charts. The Sumerians weren't just sky gazers looking for omens. They wanted their entire world, every city, every stone, to reflect the order they saw in the stars. For them, the sky wasn't just something to watch. It was the pattern to follow. Some researchers have tossed out this idea they call the cosmic city theory. Basically, they think the Sumerians didn't just build their cities wherever they felt like it. They worked off a master plan, a map or blueprint that existed before the first brick was laid. And that blueprint wasn't just a sketch on parchment, it was written in the stars. The cities ended up where they did because those spots matched up with key points in some grand cosmic geometry, a pattern that, honestly, only makes sense if you're looking down from above. You'd need a viewpoint that ties together the lay of the land and the movement of the heavens all at once. From above, just let that idea hang for a second. How do you draw a map that lines up city locations with stars if you're stuck on the ground, say, in 3500 BCE? No Google Earth, no drones, not even a hot air balloon. All you've got are ropes, sticks, measuring rods, the basic stuff. The Sumerians knew how to measure things locally, sure. But how do you coordinate cities spread out over hundreds of kilometers, all according to some cosmic pattern when you're working with those tools? Yet the evidence is right there in the ruins. The distances match up, the digs confirm it, and the math checks out. Someone, somehow, knew enough about both the earth and the sky to weave that connection into the very shape of their civilization. Either they invented surveying tricks so clever we found no trace of them, or they had access to knowledge about the world's geography from someone, or something, that had already mapped it out, that could see the big picture, that understood how distant places fit together because they'd seen them all at once. The same kind of mystery shows up in the math they left behind. At Yale, there's this one clay tablet, YBC 7289, just sitting in a collection of over 45,000 cuneiform tablets. It's not some grand monument. It's a student's exercise, the kind you'd find in a scribal school. It's about the size of your palm, just fired clay, and it's managed to survive for almost 4,000 years. Pressed into the surface, there's a simple square, its diagonals neatly marked. Nothing fancy, just a clean geometric drawing done by hand. Next to one diagonal, there's a number written in Sumerian base 60, the same system we still use for hours and angles. Turn it into our numbers and you get 1.414213. That's the square root of 2, accurate to 6 decimal places. The tablet's from around 1800 BCE, but like a lot of these things, it's probably a copy of something even older. The fact that it's a student's practice piece, not a royal inscription, tells you this wasn't some rare or secret knowledge. It was just part of being educated. Now the square root of 2 is a weird number. You can't write it as a simple fraction. The decimals go on forever, never repeating. The Greeks, living more than 1,000 years later, were thrown for a loop by numbers like this. For the Pythagoreans, discovering that the square root of 2 couldn't be written as a ratio of whole numbers was a crisis. It actually shook their view of reality. The story goes, the guy who proved it got tossed off a boat for his trouble. But in Babylon, no drama. Here, that same number calmly scratched onto a bit of clay by someone learning their trade. No existential panic, no big debate, just a tool for solving problems. You need it for geometry, for figuring out the area of odd-shaped fields, for building things that aren't just squares and rectangles. For them, it was just another part of the job. Here, what's really strange, the way they worked it out. The method on the tablet isn't just a formula, it's an iterative algorithm. Basically, you start with a rough guess, run it through a formula that gets you closer to the answer. Then you keep repeating that process, each time getting a better approximation until you're as close as you want. This approach, breaking a big problem into repeatable steps that home in on the right answer, is exactly how modern computers tackle math. It takes real abstract thinking to see that a process like this works, no matter what numbers you plug in. You have to trust the method, even if you can't see the final answer yet. We're not talking about simple arithmetic here. This is high-level math. It's the kind of thinking where you realize you might not be able to jump straight to the answer, but you can get there by circling closer and closer. And the wildest part, this method shows up on what looks like a student's practice tablet. That means the Babylonians weren't just aware of it, they taught it as basic knowledge, something every beginner should know. But where did they get it? The tablet doesn't give any backstory, no proof, no explanation, no inventor's name. It just lays out the process like it's always been there, something everyone learns by heart. But math doesn't just pop into existence like that. People have to experiment, find patterns, tweak things, make mistakes, and eventually settle on what works. Over time, those methods become standard, passed down from one generation of students to the next. Yet when we look at the oldest Babylonian math tablets, they're already filled with advanced techniques. There's nothing showing the messy trial and error stage. No half-baked attempts, no scribbled-out errors, no first drafts. The finished methods just appear, already polished, as if someone else did all the hard work and only handed down the final version. You see the same thing with another famous artifact, Plimpton 322. It's now at Columbia University, but it originally came from the ancient city of Larsa in southern Iraq. In the early 1900s, these kinds of artifacts were often scooped up and shipped to Western museums, and in 1922, George Arthur Plimpton bought this tablet as part of his collection. Plimpton 322 is a math text listing what we call Pythagorean triples, 3 whole numbers that fit the equation a 2 plus b2 equals c2. The classic example is 345. 3 squared plus 4 squared equals 5 squared. The tablet lists 15 of these triples, some with impressively big numbers, all correct, all organized in a way that hints at a general formula rather than random discovery. Here's the kicker. The tablet was made around 1800 BCE, more than 1,000 years before Pythagoras ever set foot in Greece. And yet, the tablet doesn't treat this as a big deal. It's not making any fuss, just presenting the information as everyday knowledge, like something a student would use to solve practical geometry problems, measuring fields, designing buildings, anything needing right triangles. The casual presentation suggests this knowledge was already old and baked into their math education. When modern mathematicians finally took a close look at Plimpton 322, with all our current tools and theories, they realized it wasn't just a list. It was showing trigonometric relationships, ratios behind right triangle angles, concepts that, according to the usual story, weren't formalized until the Greeks came along much later. But the Babylonians had them, and they had them so well integrated that they taught them to students as basic skills. For them, this was just another part of being educated. So where did all this theory come from? Math isn't just about noticing things. It's about going further, making connections, seeing patterns that stretch way beyond a single example. Sure, you can spot that a triangle with sides 3, 4, and 5 makes a right angle. That's observation. But when you realize any numbers that fit a 2 plus b2 equals c2 form a right triangle, that's abstraction. Then, when someone cooks up a formula to spit out those numbers over and over, that's real theoretical math. And that kind of math doesn't just fall out of the sky. It takes a lot of messing around, trying out ideas, spotting weird patterns, guessing at rules, hunting for exceptions, arguing with other mathematicians, changing your mind, and slowly building up something that actually works. But here's the weird part. The math texts from Mesopotamia look like they skipped all the messy parts. The tablets don't show rough drafts or half-baked theories. They're clean, polished, and systematic. It's as if someone already did all the hard work, figuring out the theory, testing it, making mistakes, and then only wrote down the final instructions, the parts that worked. In 2019, a group from the University of New South Wales dug into Plimpton 322, that famous Babylonian clay tablet, and published their findings in Historia Mathematica. What they found: the Babylonians had a kind of trigonometry, but it wasn't like what the Greeks came up with later. The Babylonian way was sometimes even slicker, more direct for the calculations they needed. They didn't mess with angles or circles. Instead, they used number ratios, which made their math easier to work with and, for their purposes, even more precise. So not only did the Babylonians have advanced math, but they got there on their own terms. They didn't just follow some universal roadmap to mathematical truth. They built their own system with its own rules, its own logic, and in some cases, solutions that outperformed what later civilizations managed on their own. Or maybe they inherited it. The tablets never say, "We discovered this." Instead, they're full of references to old sources, copied from ancient texts, taken from the wisdom of the ancients, following the knowledge of Anu and Enlil. You see those credits everywhere in margins and endnotes, always pointing further back, beyond what anyone remembers, from the old writings of the gods, according to the wisdom of the ancients. And those gods, Anu and Enlil, their names keep popping up, not just in myths but in mathematical, astronomical, and architectural records. Not as distant, all-powerful creators, but as the original experts, the ones who first set up the measurements, tracked the planets, invented the math everyone else just copied. If these figures were pure myth, why do the texts keep tying them to calculations and observations, not just creation stories or moral lessons? Why do the tablets give them credit for technical know-how, not cosmic commands or codes of conduct? The pattern here is pretty striking. People didn't just remember these figures as rulers or judges, even though they played those parts sometimes. They saw them as teachers of something the Sumerians called the me. These weren't just simple rules. They were the core principles that shaped everything: reality, society, the natural world. The me covered a lot: justice, kingship, how to work metal, how to do math. They called them divine decrees, but me also means something like pattern or the way things work. It's about the hidden structures that keep both nature and civilization running. Think about what's on that list: astronomy, math, surveying, city planning, irrigation. All these skills, they said, came from the Anunnaki. The ones who came down from the sky, taught people, and set things in order. If these beings were just stories, myths made up to explain where civilization started, then you'd expect Sumerian knowledge to look different. A slow build-up, lots of trial and error, a messy process. But it doesn't. It looks more like something passed down, a set of instructions handed from teacher to student, from some earlier source to later generations. Look at the evidence. The Venus tablets, the way cities are spaced, the use of irrational numbers, Pythagorean triangles, the precision, the completeness. There aren't really any half-finished versions or obvious steps in development. If you put all this side by side and don't try to fit it into what you already expect, one weird question starts to poke through. What if this stuff wasn't developed here at all? What if someone observed it from a viewpoint we've only just started to reach ourselves? The stories say the Anunnaki came from heaven, brought knowledge of the stars, taught people to measure and calculate. What if they actually had an orbital or aerial perspective, something we'd recognize from space travel? Think about what it's like to look down from orbit. Astronauts talk about how humbling and clarifying it is to see Earth from 300 miles up. Patterns jump out, patterns you'd never notice from the ground. You see how landforms connect, how rivers trace out the bones of the planet, how mountains sit on tectonic seams. Coastlines that look messy and random up close reveal a fractal order from above. Deserts, mountains, everything. There's a symmetry you just can't get at ground level. And then there's what people have built. From up there, you see how cities and settlements fit into the bigger picture. They aren't just scattered wherever. Farming villages line up along rivers. Trade hubs sit at crossroads. Fortresses rise where the ground gives an advantage. Choices that seem random or only practical when you're in the middle of them start to fit a larger pattern, a logic you can only see from way above. The geography, the human choices, the whole web, it all comes into focus from that high-up view. NASA's Landsat program has been snapping pictures of Earth from space since 1972, when the first satellite lifted off from Vandenberg Air Force Base. At first, Landsat was all about practical stuff, tracking crops, finding minerals, keeping tabs on the environment. The idea was to use overhead photos to spot things you couldn't see from the ground. People wanted to know where the good soil was, what crops looked healthy, or if a river had shifted. But the real surprise turned out to be archaeology. Suddenly, things like ancient roads, buried buildings, crop marks hinting at ruins below, stuff you'd never notice walking around, started popping up in the images. From space, you notice odd shadows, tiny changes in texture, strange patterns you miss with your own eyes. And Landsat doesn't just see invisible light. Those satellites pick up all sorts of wavelengths, and that makes all the difference. Grass grows a little differently over a buried stone wall. The soil changes where old structures rotted away. Water moves around hidden foundations in weird ways. These clues are subtle on the ground, you'd barely notice them. But from 300 miles up, the patterns come together. Suddenly, you know exactly where to dig. By the 1980s and 90s, archaeologists started digging into Landsat's archives to study ancient Mesopotamia. They took tools built for geology and farming and turned them loose on the oldest cities in the world. What they really wanted to know was how the Sumerians survived in a place where rain barely fell. The answer was water, canals, irrigation, a whole system for moving river water to the fields. It took serious planning and coordination to make that work. But the maps showed something bigger than anyone expected. Canals weren't just little ditches connecting a city to its fields. From above, you could see huge networks tying cities together. These canals didn't just meander around following the easiest route. They followed geometric paths, radiating out and linking cities in patterns that weren't obvious from the ground. Some were massive, big enough for boats hauling grain or trade goods, turning Sumer into a single economic machine instead of a bunch of isolated towns. Researchers started plotting all this data in GIS software, mapping canals, city locations, even the orientation of ancient temples. When they looked at the numbers, they found another surprise. The layout of the canals, the spaces between cities, and the way temples lined up with the stars all fit together into a single geometric pattern. It looked like somebody had drawn up a master plan. Water, cities, astronomy, all working as part of one system. You only really see this from above. On foot, each city seems to do its own thing. Every canal looks like a local fix for a local problem. But from space, the grand design jumps out. The connections between distant places, which seem random if you're just standing there, suddenly make sense when you see the whole picture. So now some researchers are asking big questions. What if the Anunnaki, those mysterious figures from Mesopotamian myth, had some way of seeing the land from high above? Not necessarily spaceships, though some folks go there, but maybe just a way to get far enough up to spot these grand patterns. If that's true, then all those old stories, the crazy precise astronomy, the math, the city planning, it starts to sound less like luck and more like inherited knowledge. Maybe they didn't figure it all out from scratch over centuries. Maybe they were holding onto secrets passed down from a time when someone, somehow, could see the whole landscape laid out before them. The tablets turned into archives, not living records of ongoing research, but collections of memories, knowledge passed down, not discovered fresh. When the old texts say, according to the old observations, they mean it. Those observations were ancient even then, older than the civilization copying them down. People made them long ago, under skis and in ways that nobody could repeat. Mesopotamian astronomers weren't mapping the planets for themselves. They were double-checking what they'd inherited, making sure the old predictions still worked, hanging onto knowledge said to come from the Anunnaki, those who came down from the sky and saw Earth as a whole. Honestly, the Sumerians' own words back this up in a way that feels almost too on the nose. When kingship descended from heaven, not a metaphor, not a poetic flourish, they meant it literally. Something came down out of the sky from a space that in their world was the air above, the atmosphere, that gap between Earth and the distant stars. The Anunnaki who from heaven to Earth came. That's not just a title, it's a direction, movement from high up down to the ground. Now imagine you're trying to describe visitors who arrived from above. They saw everything from up high, the kinds of patterns, connections, and views you just can't get from the ground. You don't have words for airplanes or satellites, nothing for technology that lets you hover or orbit. What do you say? They came from heaven. They descended. They looked down and saw the land laid out, cities, rivers, mountains, the whole thing clear as day. They saw relationships and patterns regular people could only dream about. And if those skyborn teachers handed you astronomy and math based on what they saw from above, if they gave you coordinates, measurements, and geometry that only make sense from that elevated view, you'd guard that knowledge. You'd keep it safe, word for word, always crediting the original source, because you know you didn't figure it out yourself. You got it as a gift, and losing it would be a disaster. Climbing back up to that perspective, getting that view from heaven again, forget it. Maybe impossible. There's a tablet in the British Museum, K3567. It's a piece of the huge hoard dug up from Nineveh in the 1800s, back when European museums were scrambling to collect cuneiform tablets and giant statues from ancient Iraq. This tablet's just a fragment, broken off a larger piece, snapped and battered by time. It's incomplete, sure, but what's left is enough to spark real curiosity. The text isn't a myth or a hymn. It's more like a classroom scene, a god. The tablet uses the proper symbol to show it's a divine name, teaching humans how to survey land. Not a lesson in morals or faith, not some story with a hidden meaning, but pure technique. It's the same kind of practical, step-by-step instruction you'd get from an expert showing a newbie how to do a real job. The god demonstrates how to use measuring cords, how to line up angles with simple tools, how to calculate the distance between 2 points when you can't go straight from one to the other. The vocabulary isn't poetic, it's technical, loaded with terms for surveying tools and mathematical steps. This is the language of engineers, not priests. And then, buried in the instructions, there's a phrase you don't find anywhere else in all of cuneiform: seeing from the mountain of heaven. The rest of the tablet is damaged. The lines before and after are gone, so this phrase just hangs there, a mystery. But the words themselves are clear. The grammar is direct. It's describing a view from way up high, high enough that you have to think about the curve of the land, high enough that you need to adjust your calculations because you're not standing on the ground anymore. When surveyors map out huge areas today, connecting points that lie hundreds of kilometers apart, they can't just pretend the Earth is flat. Over small patches of land, sure, you can ignore the curve and your numbers will be close enough. No one's going to notice a millimeter off here or there. But stretch your measurements across whole regions, across distant cities, for example, and that shortcut falls apart. The Earth's roundness starts to matter. You need to adjust for it if you want your coordinates to make sense everywhere. If you go ahead and treat the world like it's a flat sheet, your measurements drift farther from reality the longer your lines get. That straight line you drew on your map, on the real, curved Earth, it actually bends. Distances that look the same on a flat page end up different once you wrap them around a sphere. Figuring out how to fix these errors isn't obvious. It takes some real math, spherical geometry to be exact. You need to accept that the ground under your feet isn't flat, even if it feels that way. This wasn't always common knowledge. The Greeks, especially Aristotle and later Eratosthenes, were among the first we know of to argue convincingly that the Earth is round and to calculate its size, sometime after 300 BCE. But here, where things get interesting, if you look at the way Sumerian cities were spaced and you crunch the numbers with today's surveying tools and GPS, you find something odd. The positions of these ancient cities, the distances between them, don't quite match what you'd expect if they just used flat geometry. Instead, the layout fits what you'd see if someone had factored in the Earth's curve. It's as if they knew the ground beneath them wasn't perfectly flat, that long distances needed a correction, and that only spherical math would get the relationships right. Somehow someone knew. Someone cared enough to build that knowledge into their cities, cities that would stand for millennia. Even if their theories faded with time, the evidence stuck around, written into the land itself, just waiting for someone with the right tools to spot it. Fast forward to 2008. A researcher named Carl Monk, working on his own, started plugging ancient site coordinates into satellite mapping software. He came up with a theory he called the code, arguing that ancient sites all over the world, not just in Mesopotamia, encode precise mathematical relationships using latitude and longitude. Most archaeologists aren't convinced. They're skeptical of big, sweeping theories that try to tie together sites from different cultures and continents without solid proof of contact or shared knowledge. Still, Monk's main question is a good one. How much did ancient people really know about the planet they lived on? Did they understand its shape, its size, the math behind laying out distant points on its surface? How did they pull off such accurate measurements with the tools we know they had, tools that on paper shouldn't have been up to the job? The Greeks definitely figured it out. Back in the 3rd century BCE, Eratosthenes, who ran the library in Alexandria, pulled off a remarkable calculation. He noticed that at noon on the summer solstice, the sun stood directly overhead in Sin, modern Aswan, shining straight down into the wells. But at the same time in Alexandria, some 800 kilometers north, the sun cast a shadow, just a slight angle away from vertical. By measuring that angle and knowing the distance between the two cities, Eratosthenes worked out the Earth's circumference using basic geometry. His answer, about 40,000 kilometers. That's just a few percent off from the real number 40,075 kilometers at the equator. Not bad at all. It's a beautiful piece of reasoning, proof that the Earth is round and that its size isn't some mystery. You just have to look carefully and do the math. Eratosthenes never claimed he was the first to figure out Earth was round, or that he invented the math for measuring it. In the scraps we have of his writing, mostly bits and pieces quoted by later writers, he actually points back to even older sources. He talks about knowledge passed down from earlier traditions, stuff preserved in temple libraries, what he calls ancient wisdom that came before Greek philosophy. Basically, he saw himself as building on what others already knew, just applying it in a new way, or maybe getting a more accurate answer than the scholars before him. So could the Sumerians have had this knowledge? They tracked Venus, predicted eclipses. Their astronomy was sharp. Is it possible their observations went beyond the stars and planets, that they understood Earth itself was a sphere? The hard proof isn't there, not yet, but the clues keep piling up. Their math tables sometimes only make sense if you're working with spherical geometry, ratios and formulas that fit curved surfaces, not flat ones. Their astronomical texts describe the sky as a sphere wrapped around Earth, with the stars and planets moving in curves, not just sweeping across a flat backdrop. Look at their city layouts, the way they built canals, how their buildings line up. You see these tiny adjustments, little corrections for the curve of the Earth over distance. You don't need that if you're working with a flat world. Sure, it doesn't prove they calculated the planet's circumference like Eratosthenes, but it does suggest they understood Earth was round. They wove that idea into their engineering, their architecture, and the way they measured land. But if they knew, where did that knowledge come from? The usual story is patient observation and careful math. Watch ships vanish over the horizon, see how different stars show up at different latitudes. Notice that Earth's shadow on the moon during an eclipse is always round. All these things can point you to the truth. Eratosthenes used these tricks, and any advanced enough civilization with time and curiosity could have done the same. Still, you have to wonder, what drove the Sumerians to care? Why pour so much effort into measuring the planet itself? Farming doesn't need this knowledge. Trading goods doesn't require spherical geometry. Even navigating long distances across land or sea can be done with simpler ideas, without calculating the size of the Earth. Maybe the knowledge came first, and the uses followed. Maybe the Sumerians inherited this understanding from even older sources, stories of the Anunnaki who came from the heavens, bringing mathematics and measurements. Maybe, knowing how easily knowledge can vanish, they locked it into their cities, their buildings, their roads. So even if the tablets were lost or destroyed, the clues would stay in stone and geography. You see this habit, embedding knowledge into physical things, across Sumerian culture. Their architecture, their city planning, their huge buildings all serve purposes that go beyond the practical. Ziggurats weren't just temples or administrative centers. They doubled as observatories, with their steps echoing the layers of the heavens, their measurements hiding mathematical constants, their positions lining up perfectly with celestial events, a level of precision that took real calculation and skill. Take the Great Ziggurat of Ur. In the 20th century, archaeologists pieced it back together, helped by old texts and the ruins themselves. Its base, when you divide the numbers a certain way, gives you pi, the ratio of its base to its height. It's close to the golden mean, that mysterious number you see everywhere in nature and art, from seashells to flower petals to the proportions of the body. That kind of math doesn't just happen by accident. It's deliberate, a way to stash knowledge in stone, because stone lasts when libraries burn and archives wash away. Stand in the rebuilt courtyard of that ziggurat. Look up. The steps climb into the desert sky, and you're not just seeing bricks and mud. You're looking at a three-dimensional math problem, a structure that actually encodes relationships, numbers, the earth and sky, human measurement, cosmic proportions. And what gets me is how advanced all of it is. We're not talking about simple geometry here. The math built into Mesopotamian architecture runs deep, theoretical, stuff that stump university math students today. They understood irrational numbers, transcendental constants, things you don't just stumble onto by accident. So where did all this knowledge come from? The Sumerians didn't take credit. They said it came from the Anunnaki, and especially from Enki, the one who established the measurements and laid out the cities according to cosmic order. Enki's temple at Eridu, which is the oldest religious site in Mesopotamia, people built and rebuilt it for nearly 5,000 years, was a kind of ancient library for math and astronomy. Archaeologists have found tablets there with some of the earliest examples of sexagesimal math. This base 60 system the Sumerians used. We still use it, actually, every time we divide an hour into 60 minutes or a circle into 360 degrees. But why base 60? It's weird, honestly. If you're inventing numbers from scratch, you'd probably use base 10, counting on your fingers like everyone else. Or maybe base 12, using the segments on your fingers, which some cultures did. Or base 20, if you want to count fingers and toes. These all feel pretty natural. But 60, that's huge. It's messy to count on your hands, and it doesn't come from anything obvious about our bodies. The usual explanation is that 60 has a ton of divisors. You can cut it up by 2, 3, 4, 5, 6, 10, 12, 15, 20, 30. Make splitting things up for trade super convenient. No weird fractions, no complicated leftovers. That's definitely true. Base 60 is elegant for exactly that reason. But it doesn't explain how the Sumerians landed on it in the first place. To notice that 60 is so divisible, you have to already know a lot about numbers and how they work. You'd have to try out different systems, compare them. Actually do the math to figure out which base is best. That's not something you just stumble into by accident. This is the kind of choice you make if you understand number theory well enough to compare and judge different systems. Or maybe you just inherit the system. If your ancestors, or as the Sumerians claimed, the gods, handed it down, you keep it. If you truly believe your entire system of measurement came from beings who knew more than you ever will, you don't just drop it for something that's easier to count on your fingers. You stick with it, even if the original reason for it is lost, even if nobody quite remembers the logic behind it. The same thing goes for Sumerian astronomy. These people track the stars and planets with an intensity and precision that doesn't make sense if you're just planting crops or casting horoscopes. They did it because it mattered to them, because keeping that knowledge alive was a sacred duty. They believed they owed it to the original teachers, the first watchers. Those Venus tablets, they weren't written for some king's astrologer who just needed a rough guess. They were written for the future, to keep the thread unbroken. to make sure that even if everything else fell apart, the knowledge of Venus's motion would survive. And honestly, they had every reason to worry. Mesopotamia wasn't some stable, unbroken line of progress. It was a civilization that kept getting knocked down, sometimes almost wiped out. The Sumerian world, which had thrived for over 1,000 years, came crashing down around 2000 BCE with Amorite invasions, and the land itself giving out drought, failed crops, maybe even climate change. The city-states that once buzzed with life just disappeared. Later, the old Babylonian period fell apart around 1600 BCE. Maybe it was the Hittites, maybe their own problems inside. Then, in 612 BCE, the Assyrian Empire met its end. The Medes and Babylonians joined forces, stormed Nineveh, torched the royal libraries, and scattered everyone who survived. With every collapse, people fled, libraries burned, the chain between teacher and student broke. The risk wasn't just losing buildings or kings, it was losing knowledge itself. And yet somehow, the astronomical and mathematical secrets lived on. People kept copying and recopying them, even when the reasons for doing so faded away, even when no one really understood the original context anymore. Babylonian scribes sat and painstakingly copied old Sumerian texts they could barely read, needing dictionaries just to get through them. Assyrian astronomers kept up ancient traditions, chalking them up to the wisdom of the ancients, because they honestly didn't know where it all started. The empires that built this knowledge disappeared, but the knowledge itself stuck around, because some people, or maybe just some institutions, understood its value even when they had lost touch with its roots. Fast forward, the very last cuneiform tablet ever written dates to 75 CE. Archaeologists dug it up in Babylon in the early 1900s. 3,000 years had passed since the Sumerians invented the script. That's 3,000 years of empires rising and collapsing, languages mutating, old gods forgotten and new ones worshipped. And yet, someone was still out there, inscribing cuneiform onto clay. Not because it was useful anymore, it wasn't, but because the tradition mattered. And what was on that final tablet? Astronomical observations. Think about that. Someone under Roman rule in a city that had watched the world change for millennia still thought it mattered to watch the sky, to write down what they saw, to do it in the old script that almost no one could read anymore. They were keeping up a practice that stretched back to people who watched those same stars 3,000 years earlier, linking themselves to a chain of observation that reached all the way back to legends. The time when, according to the old stories, the Anunnaki descended from the skies and taught humans how to watch, measure, remember. But why? What drives a person in 75 CE, with cuneiform a fossil Akkadian replaced by Aramaic, the old religion mostly gone, to keep recording the stars in clay? Maybe they didn't know, not clearly. Maybe it was just tradition, or a vague sense passed down through generations of scribes and priests that this knowledge was more than just numbers and names. It was a legacy, a memory, a fragile thread tying them to something lost, something that might one day matter again, something that kept alive the ancient perspective. Those who looked down from above, mapped the world, brought mathematics and the urge to keep watch always. And if you find yourself in the ruins of Nippur or or Eridu, at that hour before dawn when the desert is silent and the wind holds its breath, it's not hard to imagine them. Astronomers standing on temple terraces, eyes fixed on Venus above the horizon counting days, marking numbers with careful hands. Scribes hunched over clay tablets, lamps flickering, wrists aching, copying lines they might not fully understand but know are important. They did this to keep the chain unbroken, to hold on to knowledge that came from before, from the time the gods themselves, so the stories go, taught humans to see the world whole. Picture that scribe working late into the night while the city sleeps. His little lamp throws long shadows on mud brick walls. Before him lies a battered tablet, its marks worn but still legible. His job? Copy it. Make another version so the knowledge lives on, maybe for another generation, maybe for another 1,000 years. He doesn't really get everything he's copying. The math is tough, way over his head, honestly. The star charts mention constellations and positions he's never actually checked for himself. All those old names, Anu and Lil, the time before the flood, they feel so remote, almost like legends, separated from his everyday life by a chasm he can't even imagine crossing. Still, he copies it all, every single number just as it's written, every symbol perfectly shaped. That's what they taught him. Accuracy comes first, understanding comes second. His job isn't to fix the old knowledge or make it better. He's supposed to preserve it no matter what, pass it on untouched to the next generation. When he's done, when the new tablet is ready and set aside to dry, he adds his little note at the end, a colophon. Name, date, source tablet, all the formal stuff. And then, according to the ancient tablet, he writes, "May it not be lost." That's the heart of the job right there. Everything he does, everything Mesopotamian scholars did, was about keeping memory alive, fighting against the slow erasing of time. That scribe died 4,000 years ago. Nobody remembers his name. His city is just ruins now. The empire he worked for disappeared ages ago, but the clay tablet he copied, or one just like it, made it through. It spent centuries in temple libraries, survived the collapse of kingdoms, got buried in rubble when buildings fell. It sat in darkness for ages while new civilizations rose up. People who couldn't read cuneiform, who never even heard of Sumerians, who had no idea what lay beneath their feet. Then much later, only a couple of centuries ago, archaeologists started digging. They figured out how to read cuneiform, and after 3,000 years of silence, the tablets could speak again. The star charts, the math, the geometry, the measurements of the earth, all of it, just as the scribe had hoped, not lost. They were trying to hold onto something, a way of seeing the world from above. Numbers that showed what Earth looked like as a whole, its shape and size and motion through space. They wanted to measure distances and relationships as if they could see everything at once, from a God's eye view. That perspective, the geometry, the patterns on the land, things ordinary people couldn't see from the ground. And somehow it worked. The knowledge survived. For a long time, people dismissed it as old superstition or confused it with myth, but it stayed. Tucked away in museum collections, in the layout of ancient buildings, in the spacing of ruins you can only really make sense of from the sky. Waiting to be recognized, not as the guesswork of Bronze Age stargazers, but as records of observations from a perspective we're only just starting to share. From orbit, from above, from heaven. Think about what that means. Now we can check their math from space. When NASA satellites capture images of ancient Mesopotamia, when archaeologists use radar and satellite photos to map old cities, they're seeing what those ancient planners must have seen. The patterns, the geometry, the alignments, stuff you can't spot from the ground, but that makes perfect sense from high above. Back in 2006, a group from the University of Chicago's Oriental Institute took a look at southern Iraq with satellite photos, hoping to figure out how the Sumerians handled their water and organized farming. They expected to see some old canals and irrigation ditches. What they found was something wild. A massive, intricate web of waterways, way more complex than anyone guessed. Canals linking cities in neat geometric shapes. Water systems that clearly needed more than a few clever engineers. They needed big-picture planning, people who could think beyond their own backyard. When they mapped these canals and laid them over the locations of major cities, a pattern jumped out. The cities weren't just plopped down for defense or easy farming. They fit into a kind of geometric grid, one that linked water systems with the stars. It was like the whole civilization was built on a blueprint that mixed practical engineering with a sense of cosmic order. And here's the kicker: you couldn't see the full design from the ground. Down there, every city looked like it was just doing its own thing, each canal a fix for some local issue. But from space, the whole plan showed up. Someone designed this. Someone saw the entire region as a unit and organized it that way. And back in 3500 BCE, the only way to imagine the whole region from above was, well, to imagine it, or maybe to know something we don't. No, the evidence doesn't force us to believe the Anunnaki were literally orbiting Earth 6,000 years ago. Archaeology is messy like that, you don't get one neat answer. Still, the evidence doesn't let you shrug off the Sumerians' claims either. It doesn't make it easy to say, oh, they just got lucky with the math, or the stories about beings from the sky are just myths. There's too much precision, too much intentional pattern, too much continuity for comfort. Here, what we do know. The Sumerians had knowledge that looks shockingly advanced for their time. They tracked things over centuries. Their math was elegant and complex. Their cities were laid out by geometric rules that embed astronomical ideas. And they credited all this to teachers who, according to them, came down from the sky, bringing knowledge from above. And then, all these thousands of years later, we finally get our own view from space. Suddenly, what the Sumerians built makes more sense. The patterns they left behind only show up fully when you're looking down from above. It's almost like they knew about a perspective we only just regained. Were the Anunnaki just humans carrying forward knowledge from a lost world? Or maybe something else entirely, something we can't really describe yet? Or maybe, just maybe, the Sumerians themselves figured all this out with sharp observation and brilliant math, using techniques we still haven't pieced together. Pick whichever theory you like. The facts don't change. The knowledge is real. The precision is real. The patterns are there, waiting for someone to explain them. And the Sumerians, the actual people behind all this, told us where their knowledge came from the sky, from above, from those who came down and commanded them to remember. What if that old phrase, when kingship descended from heaven, wasn't just poetic talk about divine right? What if it was a memory of knowledge arriving from above, from people who saw the world differently, who mapped the land from the sky, who left us numbers and measurements in the order to keep them safe? Maybe they wanted us to remember, to preserve the knowledge until we could finally see from the same vantage point and realize what we'd been holding onto all along. The question hangs there, right in the silent space between those ancient clay tablets. It lingers in the gaps between cuneiform wedges and hides inside the patterns of city layouts and architectural proportions. Were the Anunnaki actually mapping Earth from space 6,000 years ago? There's no hard proof. There never really is, especially when you're dealing with ancient texts and ruins that always seem to offer more than one answer. Still, the evidence refuses to just let it go. It won't let us settle comfortably with the idea that ancient people couldn't possibly have known what their own writings claim they knew, or that their precision was just luck, or that all those stories about beings from the sky are nothing but wild imagination. Conventional models can't really explain it. They expect knowledge to show up in slow, obvious stages, step by step, trial and error, learning through the centuries. But in Mesopotamia, the full package of knowledge just seems to appear, almost fully formed, and it leaves archaeologists and historians scratching their heads. The Sumerians themselves keep saying, over thousands of tablets and across thousands of years, that they didn't invent this stuff. They say it was handed down to them, a gift from the Anunnaki who showed up, taught humanity, then left us to keep and use what we'd been given. And then there's the strange perspective baked into their knowledge. You see it in city planning that looks like someone viewed it from above, in their use of spherical geometry to measure the land, in astronomical calculations that require seeing patterns you'd never spot from ground level. All of it points to a bird's-eye view, a way of thinking that only makes sense if someone, somewhere, could actually see the big picture, the kind of view we only got once we made it into orbit ourselves. Maybe that's why, in the last few decades, NASA has started poking around Mesopotamian astronomy. They're not making a big deal about it, no flashy projects or headline announcements. But you hear about individual researchers comparing ancient observations to modern data, running studies that check old predictions against today's calculations, or using satellite imagery to map ancient sites and spot patterns nobody could see until we started looking down from space. Among the people who straddle both archaeology and space science, there's this growing sense, quiet but real, that ancient astronomers knew more than we've admitted. Their notes might hold data we should check against our own, especially for planetary movements or climate cycles that take centuries to track. Our modern records only go back a few hundred years, to the telescope age. If we want a longer timeline, we might have to see how well the ancients' numbers hold up. Back in 2016, researchers from the British Museum and Ludwig Maximilian University published a paper in Science. They've been studying Babylonian tablets from between 350 and 50 BCE that tracked Jupiter's path across the night sky. These tablets used geometric methods to predict where Jupiter would go, actually calculating the area under a velocity time graph to figure out its displacement. That's not just impressive. It's the heart of mathematical physics, the same big idea that Newton and Leibniz would shape into calculus 2,000 years later. No, the Babylonians weren't doing calculus the way we know it today. They didn't have the symbols or the full framework, but they'd grasped the key insight. If you want to know how far something's traveled, you can find the area under the curve that shows how its speed changes over time. And they didn't just puzzle over this for fun. They used it, putting advanced math to work as a tool for predicting where the planets would go next. The researchers didn't rush to any grand conclusions. They pointed out that the Babylonians could have come up with this on their own, without any connection to the bigger mathematical ideas that would eventually become calculus. Maybe this was just a parallel discovery, a different path that led to the same insight. Still, after the paper came out, one of the team members spoke off the cuff at a conference. He wondered out loud if the method reached back even further, if it was another case of knowledge that seems to show up whole, not bit by bit. Maybe, he said, the Babylonians inherited it from older sources we can't access anymore, sources lost in time, back before history as we know it, back to the age when the Anunnaki supposedly descended from the sky and taught humanity. Earlier sources. That phrase keeps popping up in studies of Mesopotamian science. The tablets themselves talk about earlier sources all the time, ancient observations, old texts, wisdom handed down from the gods who set out the standards. And when you chase those references further, they always circle back to the Anunnaki, to the era before the flood, to a time when, at least according to Sumerian stories, those who came from heaven lived among people and taught them how to measure, calculate, observe, and preserve knowledge. So what if the flood mentioned in the king list? Then the flood swept over. Wasn't just some local disaster, big for the region but limited. What if it was actually tied to the huge environmental shift at the end of the last ice age, when the world's glaciers melted, sea levels shot up over 100 meters, and coastlines people had lived on for ages just vanished? The planet's geography rewritten almost overnight. Between about 12,000 and 10,000 years ago, Earth went through wild changes. The Pleistocene gave way to the Holocene. Temperatures climbed fast, ice sheets that had covered North America and Europe broke apart, and all that ice turned to water and flooded into the oceans. Places that had once been dry ground, because sea levels used to be far lower, were swallowed by the sea. Ancient coastlines became shallow seabeds. It's hard to wrap your head around how massive this flooding was. Today, we take stable shorelines for granted, but back then, most of the world's water was locked up in ice. The map looked completely different. The Persian Gulf, for example, wasn't a gulf at all. It was a broad river valley, fertile, green, where the Tigris and Euphrates met and flowed across land that's now underwater, finally reaching the sea far south of today's shoreline. If people lived in that valley during the Ice Age, if they built villages in what must have seemed like the perfect spot, with good soil, fresh water, a gentle climate, and shelter from harsher conditions farther north, those communities are now buried beneath more than 100 feet of water, lost, out of sight. We can't even start to look for them until underwater archaeology catches up. But we know people were around. Archaeological digs in the Zagros in the Levant, along the Arabian Peninsula, all show that humans have been in the region for tens of thousands of years. And these sites aren't just campfire rings. Some have real structures, signs of long-term living, even evidence of trade networks stretching for hundreds of kilometers. If those kinds of people also settled the now submerged river valleys and coasts, what happened to them when the world warmed, the ice melted, and the water rose? The flooding wasn't instant, but for the people living through it, it must have felt unbelievably fast. Sea levels climbed about 120 meters in just a few thousand years, but it didn't happen at a steady pace. The water rose in big jumps, with calm periods in between. Around 14,000 years ago, there was meltwater pulse 1A. Sea levels shot up by 16 to 25 meters in less than 500 years. Another jump came 11,500 years ago. Then, about 8,000 years back, the last big pulse brought the seas almost to where they are now. Think about what it must have felt like to live in a coastal settlement, your family rooted there for generations. Life's steady, fields are green, trade is good, people know their place in the world. Then little by little the sea starts creeping in. At first it's barely noticeable. The river mouth shifts, the delta shrinks, and after a while the water's right at your doorstep. You have to move. You rebuild farther inland, but the sea just keeps following. There's no stopping it. Over time, centuries really, the map changes. A valley turns into a bay. Open plains sink under shallow seas. Whole islands vanish. And unless someone manages to save what matters most, the knowledge, the stories, the skills, it all disappears beneath the waves. The only hope is that survivors carry a piece of it forward, passing it to people on higher ground who didn't see the flood themselves. This is where the Sumerian flood stories stop being just myth. The Epic of Gilgamesh, Atrahasis, Eridu Genesis, they all tell the same tale. A massive flood wipes out the world. A single family survives on a boat. Life starts over when the waters finally go down. We're used to thinking of these as wild exaggerations about local disasters, stories that grew and morphed as they spread by word of mouth. But what if there's more to it? What if these are memories of something real, something huge, passed down for thousands of years until people finally wrote them down? The Sumerian stories could preserve ancient memories from the end of the Ice Age, when the seas rose over 100 meters and swallowed coastlines everywhere. Survivors might have fled inland, eventually settling in places like Mesopotamia and bringing their old world's knowledge with them. Let's say there really was a population living around the Persian Gulf during the Ice Age. If they had astronomy, math, surveying, stuff we think of as the building blocks of civilization, that knowledge wouldn't have vanished with the flood. Some of it would have survived, carried by refugees, kept alive in stories and lessons, and then finally written down when the Sumerians invented cuneiform around 3400 BCE. That could explain why Sumerian civilization seems to appear out of nowhere, already so advanced. They weren't starting from zero. They were documenting knowledge preserved across generations, knowledge born in settlements now lost beneath the sea, cultures we'll never name because the flood erased them before anyone could write their stories. Now, underwater archaeology in the Persian Gulf is starting to turn up intriguing clues. Sonar has picked up shapes on the seafloor, maybe old structures, now hidden under mud and sand. Divers have found stone tools and pottery at depths that used to be dry land. It's not proof of a lost civilization, not yet, but it's enough to show people lived there before the flood, in places that are now underwater. If those coastlines once held settlements, maybe even thriving ones, they were wiped out, not just damaged. Gone, buried under ocean and silt, invisible until we developed the tech to find traces of them. And what if, before the flood, there really was a group of people, maybe even a kind of civilization, who figured out things we're only just beginning to grasp? What if they had ways of seeing the world from above, whether by flight or something else entirely, that let them map the Earth, understand its shape, and connect distant places with a precision that surprises us even now? Maybe some of that knowledge slipped through the cracks of history, carried across generations, finally surfacing in the earliest writings of Mesopotamia. What if some people actually made it through the disaster? Not everyone, maybe not even a lot, but just enough to keep the most important knowledge alive. The stuff that took ages to figure out, mapping the stars, building up mathematical systems, measuring the planet with techniques that needed real skill and time. Imagine these survivors, refugees from a world swallowed up, desperate to save what they could after everything fell apart. No roads, no order, people scattered everywhere. They decide the only way forward is to hide their knowledge right inside the bones of the next civilization, Sumer. They teach the newcomers to watch the sky, to measure and record, to write things down on clay and carve it into buildings. They build in backup after backup, storing wisdom in so many places that if one gets lost, another survives. They train priest astronomers to keep the watch for centuries. They set up schools where math is handed down as a gift from the gods. They lay out cities in patterns that only really make sense if you're looking from above. That would clear up a lot, honestly. Why the Sumerians had such sharp precision with almost no lead-up. Why their knowledge seems finished, not pieced together over generations. Why they always pointed back to teachers from some forgotten time, always credited the Anunnaki, the ones who came from the sky. It would explain why they saw themselves as caretakers, not inventors, students, not discoverers. They kept what they'd been given, the numbers, the measurements, the command not to forget. It's just a theory, sure. The clay tablets won't tell us outright where the knowledge came from. Archaeology can hint but never show us for sure. We can map city layouts, crunch the numbers, study the math, track the stars in their records, spot patterns that suggest someone was looking down from way up. But we can't prove who had that bird's eye view. We can't show that someone actually observed Earth from orbit 6,000 years ago. We can't say the Anunnaki were anything but ancient stories, maybe twisted echoes of something real. But the evidence won't just disappear because it's weird. The accuracy is sitting right there, pressed into clay, built into the city grids, carved into the stones. The Sumerians knew things they shouldn't have, at least if you believe every culture is supposed to grow knowledge slowly, step by step. They had perspectives that don't fit the technology we know they had, ways of seeing the world that would have needed a view from above. They kept records that demanded generations of steady observation, tracking Venus, Jupiter, Saturn with a dedication that only makes sense if you've got stable institutions lasting centuries. And they told us, again and again, in thousands of little ways, where they thought their wisdom came from above, from the sky, from those who came down, taught, and told them to remember. We call it myth because the alternative feels impossible. Ancient people couldn't fly. They couldn't see the world from space. They couldn't have mapped it all out from above. So their stories about visitors from the sky must be just made up, ways to explain the world when they didn't understand it, nothing more than old tales. But now here we are, looking down from orbit ourselves. We spot patterns from space that nobody could see from the ground. We use this view to find lost ruins, to make sense of how they built their cities. We measure old buildings with satellites, and suddenly, geometric secrets show up. We've finally got the vantage point the old knowledge always seemed to expect. We're in the spot where the Anunnaki supposedly stood. We see what they claim to see. And honestly, the ancient knowledge starts to click. From up here, 300 miles high, Earth tells a different story. Plot out the old cities on a satellite map, and geometric shapes pop up. Canal lines, hidden at ground level, stretch between settlements in ways that match up with the stars. Proportions cut into stone and land finally reveal themselves. And those clay tablets, stored in museums all over the world, still whisper their secrets, recordings, calculations, and that stubborn insistence that their teachers came from above, no matter how many times we call it fantasy. What if we've been reading all this evidence upside down? Maybe mythology isn't just early people inventing gods to fill the gaps in what they couldn't explain. Maybe it's not just comfort stories about powerful beings controlling mysterious forces. What if instead it's memory? survivors doing their best to hold on to something real, but forced to use the language they had. Maybe they called it divine descent, not because they were superstitious, but because they saw something they couldn't explain without technology or modern science. Imagine running into knowledge that dropped out of nowhere, perspectives no one on the ground could reach, numbers and measurements that didn't fit what they knew. Maybe they met people or something else, who survived an earlier disaster, who could do things no one else could, who taught them, shared what they knew, and then vanished, ascended to the heavens, leaving only the instructions, the math, and the command to remember. Even now, the wind sweeps over the ruins of Nippur, picking up dust that was once mud brick, once temple walls, once clay tablets covered in skywatching records. In the quiet, climate-controlled rooms of museums, fragments sit behind glass waiting. The evidence doesn't shout, it just endures, precise, patient, stubborn. Those numbers, they track Venus's path dead on. The ratios, they encode Earth's curve in the way cities are spaced. The geometry, it puts the heavens right onto the map of the land. This is math that shouldn't exist at that time, but there it is. If you walk through Nippur's ruins today, if you stood where the Nippur once reached for the sky, you'd see a landscape that looks empty and dead, just broken mounds and bits of pottery. The temples are gone. The libraries have turned to dust. The old canals that once brought water from the Euphrates are nothing but buried traces under sand. But if you close your eyes, let the wind and the silence in, you start to feel it. The weight of history, the depth of time stacked up in those mounds. Not just one city, but many, layered over 3,000 years. People lived here, watched the sky, kept records, generation after generation. They took the job of observation seriously. They didn't just look up, they measured, they wrote it down, they tried to preserve whatever knowledge they believed had come down from the heavens. Underneath, the ziggurat's foundation still waits, its core eroded but not gone. You can still find the outlines of the courtyards where astronomers once stood, their shapes recoverable if you dig carefully enough. Their measurement units, the Sumerian cubit, the double cubit, still show up in doorways and rooms. The knowledge isn't lost. It's just waiting, as patient as the desert, for someone to ask the right questions, to look at what's really there instead of what they expect. And over on those tablets, you find the same line in the margins and notes. According to the old observations of Anu and Enlil, the ones who came from the sky, the ones who set the rules, the measurements. If you take the Sumerians at their word, even for a moment, it's like they're telling us their maps of Earth came from a view above, a perspective we're only just getting back with satellites and rockets. The evidence doesn't ask for belief. Science doesn't work that way. Evidence just sits there, showing patterns and oddities and things that don't fit. We build theories to explain what we find, we test them, we throw them out when they don't fit anymore. The orbital perspective idea, the thought that maybe Mesopotamian knowledge came from someone or something who saw the world from above, is just one theory among many. But you can't ignore it. You can't just brush aside the stuff that doesn't fit. You have to sit with the weird facts. You have to admit, these people were more capable, more careful, sharper than we usually give them credit for. They watched and measured and understood things deeper than the slow, step-by-step model of progress suggests. And when they said where their knowledge came from, when they repeated for centuries that it descended from above, maybe, just maybe, they were trying to hold onto something real, using the only words they had. The stars keep spinning above the desert, just like they have for 6,000 years. Venus still rises before dawn, following the same path the old tablets mapped out with eerie precision. The constellations the Sumerians watched are still up there, moving through the same patterns, tracing the same ancient story across the sky. In the quiet, right there in that space between what we know and what we've already brushed aside, a question lingers. It slips into the hush before sleep, never loud but always there. You can almost feel it settling in, just as your mind drifts at night. It's the question those old clay tablets seem to ask, the one hidden in the layout of ancient cities, tucked into the perfect lines of their buildings, whispered by the numbers scratched onto weathered stone. What if the Anunnaki really did map Earth from above 6,000 years ago? What if the view from heaven wasn't just a metaphor but the real thing? What if all that knowledge, etched in cuneiform, carved into city plans, baked into the math tablets copied over centuries, means exactly what it says? Imagine someone watching from the sky, measuring the land from orbit. Maybe that's the perspective we lost, the one we're only now starting to find again. It's the inheritance of those who came down, taught us, and then left us looking up, counting days, keeping records, trying not to forget. Through empires rising and collapsing, through whole languages vanishing and getting rediscovered, through stories fading into legend, Sumer was almost just a myth until archaeologists brought it back into the light. The clay remembers. Fired and stubborn, it holds on to stories in a way paper and hard drives never will. If we keep the archives safe, if we keep up the work the first Sumerian scribes began, those tablets will still be here in 4,000 years, outlasting us, outlasting almost everything. And those proportions, those ratios, they're everywhere, built into the stones, woven into the land. Even if every tablet crumbled and every written word disappeared, those numbers and patterns would still be out there, waiting for someone to notice, waiting for the right question to unlock them. The math holds up. We still use their base 60 numbers every time we read a clock or mark an angle. Their geometry shapes how we survey land, how we draw up buildings. Their astronomy, those careful notes made 4,000 years ago, still feeds into how we track planets, how we watch the weather change. And the testimony is still there, pressed into wet clay by hands that knew they were saving something important, something fragile, something that might matter again someday, when we remembered how to see the world from above. Knowledge came down from the sky. Maybe it was divine, maybe just people passing down what they'd learned, maybe the Anunnaki were real, maybe just symbols for something we can't name. Maybe they looked down from orbit, or maybe it's a perspective we still don't understand. Either way, the wisdom came from above, and it stayed down here, locked in clay and stone, in numbers and buildings, in careful notes and endless copying. It survived because a civilization believed it was their job to guard something bigger than themselves, to hold on to a knowledge they didn't invent, but knew they had to keep alive. Maybe one day, when we finally learn to read the old records with fresh eyes and a new sense of what they really mean, when we have the tools to dig deep under the Persian Gulf and all those ancient coastlines lost to the Ice Age, we'll get it. Not just what the Sumerians wrote down, but who showed them how to keep these records, and why it mattered so much that they kept the practice alive. Through empire, disaster, collapse, even in moments when they must have wondered if anyone would ever read their tablets again. They couldn't know if their knowledge would survive, or just fade out with the dust of their deserted cities. The answer sits in the silence, hides in the lines of half-buried ruins just visible above the sand, in the way ancient cities line up when you look down from a satellite, hundreds of miles above Earth, in the exactness of numbers pressed into clay by scribes who died 4,000 years ago, but whose marks still speak now. The Sumerians seemed to know they'd inherited something rare, maybe even sacred. They put everything into preserving it, even if they didn't fully grasp it, even if the real meaning was already slipping into legend by the time they started writing. Watch the sky, write down what you see, trust the old records. They came from people who saw further than we have, from a perspective higher than ours, almost as if from heaven, from above, from a view where Earth is whole and knowable. The Anunnaki descended, whatever they were, whoever they were, whether they were real or became symbols. They mapped, they measured, they taught. Their lessons sank in, got woven into the heart of a civilization that lasted 3,000 years. We're still shaped by that knowledge, whether we realize it or not. They left clues everywhere, in math, in architecture, in the way their astronomy still lines up with the stars. They waited for us to catch up, to see Earth from space, to recognize the patterns they saw, the relationships they measured, the knowledge they fought to save. Imagine holding a memory of Earth from orbit, 6,000 years before we thought such a thing possible. Knowledge from above, pressed into clay, copied and recopied, surviving disaster after disaster, waiting in museum storerooms and buried in old cities for someone to finally ask the right questions. You can feel the certainty in those clay tablets, the confidence of scribes who spent long nights making sure knowledge survived. They believed someone would look up one day, see Venus rising in the east, measure the old city grids from space, run the numbers on Babylonian astronomy, and remember. Remember that we were taught, that knowledge really did descend, that someone once had the perspective from above, lost it, and now, maybe, we found it again. Whatever the Anunnaki were, wherever they came from, they left us a message written in the stars and baked into clay. It's been waiting for us to climb back up, to reach the heights where those first observations were made, and finally see what they wanted us to see. The desert wind still carries that memory, across the ruins of Nippur, Eridu, through the quiet at night, into those hours before dawn when Venus rises and the stars keep turning, just as they have for 6,000 years. You can almost hear the whisper of those who came from above, who mapped and measured and taught, who left us watching the sky and waiting for the moment of recognition. That moment is now. We look down at Earth from space. We see what they saw, and in that recognition, in that wonder, we remember. The Anunnaki did descend from heaven, and maybe, just maybe, we're finally ready to understand what that really means.